Welcome to my channel. I'm Sir Jeff and today's lesson will be from Chapter 2, Units and Measurements. Units and Measurements. Now in physics, much importance is given to measurements. Hence it is sometimes called an exact science or the science of measurements. Now all the physical laws which we are going to study, all these laws can be expressed in terms of quantities which we can measure directly or indirectly. For example, if we have an object here, then this object is stationary. But if I apply a force in this direction, then this object will move in this direction. And if I apply a force in this direction, then this object will move in this direction. Now, according to Sir Isaac Newton, a body will remain to be in a state of rest or of uniform motion unless until acted by an external force. So this body will be in a state of rest unless until I apply an external force. And this body will be in a state of motion. So if I apply a force in this direction again, it will be in a state of motion. Now how will I measure the force in which I required to move this object from this position to this position? Now the force can be measured if quantities like mass of the object and acceleration of the object is known, and that force which is required to move an object is given by this formula: F is equal to mass into acceleration. Now this formula can be derived from Newton's second law of motion. So your force here is equal to mass into acceleration. So if we know what is the acceleration and what is the mass of the body, then we can find out the force. Now what is acceleration? Acceleration can be defined as the rate of change of velocity, and its formula is equal to velocity divided by time. And what is velocity? Velocity is defined as the rate of change of displacement, or its formula can be written as V to be equal to displacement by time. Now all these, they are average quantities. Like this one is the average velocity and this is also the average acceleration. Now these quantities which we can measure directly or indirectly, they are known as physical quantities. Okay, so physical quantity, they are quantities in which the laws of physics can be expressed and in which we can measure directly or indirectly. For example, force, mass, acceleration, velocity, time, displacement, all these quantities, they are called physical quantities. Now if we look at this quantity here, the displacement, now this I cannot express in another term. Okay, for example, like velocity I can express as displacement by time. Acceleration I can express as velocity divided by time. Force I can express as mass into acceleration, but this displacement I cannot express it in another quantity, in another form. So such quantities, they are known as fundamental quantities, and even time also, they are known as fundamental quantities. So here this quantity, and even this quantity here, mass, these are known as fundamental quantities. But quantities like velocity, acceleration, force, they are known as derived quantities. Okay, so this velocity can be expressed in terms of the fundamental quantities, displacement or distance, and time. Acceleration can be expressed in terms of another quantity, velocity by time. Force can be expressed or can be derived from mass and acceleration. So these quantities, force, acceleration and velocity, they are known as derived quantities, and quantities like mass, distance or displacement and time, they are known as fundamental quantities. So what is a physical quantity? A physical quantity is a quantity which we can measure directly or indirectly. For example, take the length of this stick diagram. Alright, now if I want to measure the height of this stick diagram, then what I can do is I can take a scale and just use this scale and measure the height of the stick diagram, and here it comes out to be around 8 centimeter. Okay, so the height or the length of this stick diagram, or this person here, this is equal to 6 centimeter. So this height here, this is a physical quantity, and to measure this height, what we'll have to do, we'll have to compare this height with this known standard reference. Okay, so here this is a centimeter scale, and here we have all the scales in terms of centimeter. So this is a known standard reference. So we compare the height of this with this, and we'll get it to be equal to 6 centimeter. And you can see here the physical quantity h has a numerical value, and it also has a size, centimeter. So this 6 here is known as the numerical value, and centimeter is known as the size of the unit in which we have chosen to measure the height of this person here. Any physical quantity Q is usually expressed as NU. Okay, and U is known as the size of the unit in which you measured the physical quantity, and N is known as the numerical value. So here N, this is known as the numerical value. Numerical value of the unit, and U, this is known as the size of the unit. Size of the unit. Okay, so we can measure this one. The size of the size of the unit can be different. See, here it's given in centimeter, but I convert this one into meter also. I know that 100 centimeter, this is equal to 1 meter. So 1 centimeter, by cross multiplication, I'll bring this one here. So 1 centimeter, this will be equal to 1 by 100 meter. So 6 centimeter, this will be equal to 6 by 100 meter. And 6 divided by 100, this will give you, so H can be expressed as 0.06 meter. You can see here the numerical value is small when the size of the unit is large. Okay, so you can also express in terms of millimeter, which is smaller than the centimeter. Now meter is much larger than centimeter. So here, if the size of the unit, which is meter, is large, then the size or the numerical value will be small. See, in centimeter is how much? 6 centimeter. In the meter is how much? 0.06, which is lesser than 6. So if your size of the unit is large, again the numerical value will be small. So all physical quantities can be expressed in this way. Okay, so here This is known as a unit of measurement. Meter is known as the unit of measurement. Centimeter is also known as the unit of measurement. So how would you define a unit? A unit can be defined as the chosen standard of reference which we can use to measure a physical quantity. Okay, and we'll have to compare the physical quantity which we are going to measure with this chosen standard of reference. For example, here we compare this height with this chosen standard, which is a unit of centimeter, to get the height of this stick person. Now we know that there are fundamental quantities and derived quantities. So physical quantity has two types. One is fundamental quantities, and the other one is derived quantities. Now fundamental quantities, they are quantities like mass, length and time. These are known as fundamental quantities, and derived quantities are that of force, acceleration, velocity, momentum, and so on. So we have fundamental quantities like mass, then we have length, then we have time. These are known as the fundamental quantities. Three fundamental quantities. Now the unit of mass, which is usually in kg, this is known as the fundamental unit. And unit of length, which is in meter, this is also known as the fundamental unit. Time, which is in second, these are known as fundamental units. Okay, so the unit of fundamental quantities, they are known as fundamental units. For example, kg, meter and second. And the unit of the derived quantities, for example, like force has unit of Newton. Then the acceleration, has unit of meter per second square. So the unit of force, acceleration, these are known as derived units. Okay, so you can see here acceleration. See, this can be expressed in terms of the fundamental units, which is meter and second. Even force also, this can be expressed in terms of the fundamental units, mass, okay, the kg, which is the unit of mass, and meter per second square. So this is another unit for force. Okay, so force, the unit of force, Newton, can be expressed in terms of, you can see, kg, meter per second square. These are the fundamental units. Okay, so we have two types of units: fundamental units and derived units. Now there are different systems of units which are being used in different parts of the world. For example, the CGS system. Now in this system, we measure length in terms of centimeter. Length is measured in terms of centimeter. Then the mass is measured in terms of gram, and time is measured in terms of second. So this CGS system, this system of unit is it was set up in France, and they measure length in terms of centimeter, mass in terms of gram, and time in terms of second. That's why we have CGS system. Another system of unit is the FPS system. FPS system. Now, in this system of unit, we measure length in terms of foot, then the mass in terms of pound, or simply lb, and time in terms of second. So in this FPS system, length is in terms of foot, mass in terms of pound, and time is in terms of second. So this system of unit is used in the Britain, okay, in England, and the third system of unit, MKS system. MKS system. So here length is measured, since we have M here, so it's measured in meter. So the length, this length is measured in terms of meter. Then mass, this is measured in terms of, since K we have kg, and time is measured in terms of second. That's why we have here the MKS, length in meter, mass in kg, and time in second. At present, the international accepted system of unit is the International System of Unit, or the SI unit. Okay, and in this system of unit, apart from the three fundamental quantities which have known, which is mass, length, and time, there are an additional 4 fundamental quantities and 2 supplementary quantities. And the 4 additional fundamental quantities, they are electric current, temperature, amount of substance, and luminous intensity. So these are the 4 additional fundamental quantities in this system of unit. And the supplementary quantities, or the supplementary units, are the units of this angle, the plane angle, and the solid angle. Okay, so for length in SI unit is measured as meter, mass is measured as kg, and time is measured in second, electric current is measured in the ampere, and temperature is measured in Kelvin, and amount of substance is measured in mole, and the luminous intensity is measured in candela. And we have the supplementary units, which is the unit of plane angle, which is radian, and the solid angle, which is steradian. So these are the international system of unit which is being used, okay, as a standard of measurement to measure any physical quantities. Now in lower classes, you must have measured the angle between the 2 lines in terms of degree. Say this is probably around 30 degrees. So the angle between these 2 lines is in terms of a unit degree. But in SI unit, we'll have to measure this angle, which is also known as the plane angle, in terms of radian. And how will we define radian? Now your radian is defined as the arc length of a circle and divided by the radius of a circle. So here what you'll have to do is you'll have to draw an arc length of a circle, and if this is the arc length, then this is the radius. And if the arc length says ds and the radius is r, then the radian can be measured in terms of ds divided by the radius. So this is the plane angle, and this is your angle in terms of radian, or simply RAD. Now for example 360 degree, if we take 360 degree is so this is your 360 degree. So this angle here is the angle 360 degree. So this is what you measured as 360 degree. Now in terms of radian, what will this angle be? So we can use this formula, arc length divided by radius. Now the arc length is this length from this point to this point again. So this length is the circumference of the circle, and if r is the radius, then your 360 degree in terms of radian will be equal to the arc length, which is the circumference, 2 pi r, and divided by the radius r. So 360 degree, if you cancel this one, you'll get 2 pi. So your 360 degree is equal to 2 pi radian. So this is the unit of plane angle in terms of this. So 360 degree will be equal to 2 pi radian. So remember, in the class 11 we shall measure angle in terms of radians, and we can convert any angle in terms of degree to that in terms of radian. For example, the 360 degree I have shown you, 360 degree, this is equal to how much? 2 pi radian. Okay, so 1 degree will be equal to 2 pi divided by 360 radian. Right, so if you want to find the angle of 180 degree in terms of radian, what you do is you multiply 180 degree both sides, so 180 degree, then here also 2 pi by 360 degree, you multiply here also 180 degree radian, then okay, then we can cancel this 2 and this cancel, so what you get is pi radian. So by using the formula, this formula, we can convert any angle in degree into a radian. Okay, so this is not required there. Okay, so 1 degree is equal to 2 pi divided by 360 radian. So this you can use to convert any degree into radian. Measurement of length. Now what is the SI unit of length? The SI unit of length is a meter, and there are various ways in which you can measure length of any object. One way is known as the direct method, that is you take any scale, for example the centimeter. If you want to measure the length of the marker, then you just take the scale and you just compare it with this length of the centimeter or length of this marker, which comes out to be around 13 centimeter. Okay. You can also have other instrument which can measure the size or the diameter of the wire. Right? You can measure the thickness of a thin sheet or a paper. Okay, and those instruments, one of those instruments, they are known as vernier calipers. Another is the screw gauge. These instruments you'll be doing in your practical classes. Okay, you can measure the thickness of a sheet You can measure the diameter of the wire, the diameter of a sphere. Okay, so such methods are called direct methods. Another method is indirect method, and in this indirect method we use to measure the distance of very large, very distant objects. For example, the distance of a very distant planet from the Earth, or of a very distant star from the Earth. And for example, we take this as the surface of the Earth, and this is the planet or the star in which we want to find out the distance from this star to the Earth. Okay, and the method that we're going to use to find the distance from this planet to the Earth is known as the parallax method. So what we do is we observe this distant planet from this point here on the surface of the Earth, and let's say this point is A. Then we find out the distance. Here we'll have to find out this D. Then again we observe this planet at this point B. Okay, so we observe this planet from two different points or two different positions on the surface of the Earth, and see, this one is a known distance B, and what we'll have to do here is we'll just have to find the angle theta. Okay, remember, you'll have to find out this D, distance of the distant planet from the surface of the Earth. So if you know the value of B and theta, then you will know the value of D. Now this B here is taking to be the arc length, D is taking to be the radius of a circle, and theta is the plane angle. So from your definition of your radian, theta is equal to the arc length B divided by the radius D. So the distance of the planet S from the Earth will be given as B by theta. Okay, so this is the distance of this planet S from the surface of the Earth, and this is known as the indirect method. Okay, so that is one way of measuring large distances. Now the sizes of objects vary over a very wide range. For example, the nucleus is very small, and the diameter of the nucleus or the size of the nucleus is of the range 10 to the power minus 15 meter. This is very, very small, and this 10 to the power minus 15 meter is known as 1 Fermi. So here 1 Fermi, this is equal to 10 to the power minus 15 meter. So in order to measure the size of the nucleus, we will not use this unit meter, but we will use this 1 Fermi. Okay, and this 1 Fermi, we can write this one as 1 femtometer, also known as femtometer. And the size of an atom is of the range of 10 to the power minus 10 meter. Again, here also this 10 to the power minus 10 meter is called angstrom. So 1 angstrom is equal to 10 to the power minus 10 meter, or we can write this one as 1. This is the unit for angstrom. So these are the ranges of the length of very, very small distances, that is the size of the nucleus and the size of the atom. So these are units which we use to measure small lengths or small distances. Then if we take the distance of the large sun from the earth, then that distance is also very, very large. And the distance and the average distance of the sun from the earth is usually equal to approximately equal to 1.5 into 10 to the power 11 meters. This 10 to the power 11, this is a very large distance, and this is known as the astronomical unit. So 1 astronomical unit this is equal to 1.5 into 10 to the power 11 meter, and is the average distance of the sun from the earth, and this we can write as 1 AU. Okay, so this unit is used to measure large distances. These units, they are used to measure small distances. Then another unit which is used to measure large distance is that of a light year. Okay, so what is a light year? You can define a light year as the distance that light travels with a velocity of 3 to the 10 to the power 8 meter per second in 1 year. Okay, so 1 light year is equal to distance traveled by light in 1 year. Okay, so distance traveled by light in 1 year. Okay, so this is a unit of distance. Okay, remember, don't be confused because we have a year here. It doesn't mean that it is the unit of time. It is the unit of distance. Now, what is the speed of light? We all know that the speed of light is equal to 3 into 10 to the power 8 meter per second. So this means that light travel a distance of 3 into 10 to the power 8 meter in 1 second. So in just 1 second, light travels a distance of 3 into 10 to the power 8 meter. So if it travels in 1 year, then what will be the distance? So here we'll have to find that out. Okay, so in 1 second, 3 into 10 to the power 8 meter, then what will be the distance traveled in the 60 second or in 1 minute? So I'll write it here. In 1 second, the distance travel is 3 into 10 to the power 8 meter. Okay. Then in 60 second or 1 minute, what is the distance? You'll have to multiply this with 60. So this is for 1 minute. Then for 1 hour, that is 60 minutes, how much will be the distance? So for 1 hour or 60 minutes, what will be the distance? You'll have to multiply this one again with 60. 3 into 10 to the power 8. This is for 1 second. This is for 60 seconds. That is 1 minute. And this is for 60 minutes. That is 1 hour. Then for 24 hours, that is 1 day. for 24 hour will be 3 into 10 to the power 8 into 60 into 60. This is for 1 hour. Then for 24 it will be into 24. So this is for 1 hour or 1 day. Now in a year, how many days do we have? In a year we have 365 days. Okay, so this is for 1 day. The distance traveled is 3 into 10 to the power 8 into 60 into 60 into 24 meter. So for 365 days, what will be the distance? 3 into 10 to the power 8 into 60 into 60 into 24, then into, this is for 1 day, for 365 days, that is a year, is this much. Okay, so this is for 365 days is for 1 year. And if you calculate the distance, this will come to be around, if you use your calculator, this will come to be around 9.46 into 10 to the power 15 meter. So this is the distance traveled by light in 1 year, and this is known as light year. 1 light year is equal to 9.46 into 10 to the power 15 meter. So 1 light year, these are units of very large distance, okay, to measure the distance of planets, to measure the distance of stars, okay, from the Earth. We can use light year or astronomical unit. And there's another unit for large distance, it's known as parsec. And parsec is the distance at which an arc of length 1 astronomical unit subtends an angle of 1 arc second. That is another unit for measuring large distance, 1 parsec. Now what is the SI unit of mass? Now the SI unit of mass is kg. And how do you measure mass? Now in order to measure mass, so what you can do is we can go to a vegetable vendor, and if we ask for 1 kg of potato, then how will the vegetable vendor measure it? What he'll do is he'll use a scale, and he'll compare that potato, okay, with a known mass. For example, you have a known standard mass which is 1 kg. He'll put it in another scale, the potato put in another one. Then he'll compare the two masses. If they are equal, then the potato is of that mass. So that's one way in which you can measure mass, by comparing it with a known quantity. Okay, and the SI unit for it is kg. Now there's another unit in which we'll have to use to measure the mass of very, very small objects. For example, the mass of the atom or the mass of the nucleus. In order to measure such mass, we'll have to use another system of unit which is called Unified Atomic Mass Unit. This unit is used to measure the mass of very small object like the nucleus and the atom. Now what is the SI unit of time? The SI unit of time is second. And how do we measure time? Okay, to measure any time interval, we simply need a clock. For example, my watch here, I can use this watch to measure a time interval, okay, between any time. So this is an analog watch. I can also use a digital watch. Okay, so this is my digital watch, and I can use this also to measure the time interval. Alright, now there's another clock which is known as the pendulum clock, and in the pendulum clock, okay, we have a pendulum which swings, which completes one vibration in 1 second. So the one vibration of the pendulum clock is taken to be 1 second. Now there's another clock, okay, or watch which we use to measure time, and this is known as the atomic clock, okay, or the cesium clock. Now just like the pendulum clock, which second is taken to be one vibration of the pendulum clock. So similarly for this atomic clock, the second is taken as the time needed for 91926317770 vibrations. Okay, in the pendulum clock, okay, the wall pendulum clock, okay, 1 second is taken as the time needed for one vibration, but here, okay, in the atomic clock, the second is taken as the time needed for 91926317770 vibrations, okay, of the cesium atom. So this atomic clock is very, very precise, and it is linked with the Indian Standard Time. So if you have your watch, if you look at the watch, now that watch, whatever time it's saying, that is linked with this atomic clock, which is maintained, or which is measured in this NPL, which is National Physics Laboratory in New Delhi. Okay, so this lab in New Delhi is used to maintain the Indian standard of time by using this atomic clock.